Up challenge. First one, level 1, 3 fractions, because this is a fraction. The first fraction has to be less than the blue one, and then the blue one has to be less than the next green one. Okay? There's lots of answers that work, but they have to be less. None of them can be equal, so they all have to be less than each other. And then, as the extra challenge, which one can you come up with so that there's the smallest difference between the two green ones? How close can you get the two green ones together so it still follows the rule? And then the biggest difference. How big of a difference can you get between the green ones? Okay? Again, using 0 through 9, no repeats. So you can't repeat. And then level 2, same thing, except that uses all 10 numbers. Can you get 2 that the green ones are as close together as possible? And 2 where the green ones are farthest away as possible. If you haven't grabbed a scrap piece of paper, I have it up at the front. He's got one. So it's just a startup. Just try to find ones that work. And when you're trying to find the difference, if you want to use your calculator, you can do that. You can change them to decimals and use your calculator. How to change something to a decimal? You just have to do 1 divided by 9 and push enter, and you'd find out what that one is. Right? That's what it is. Oh, and you knew that one from the other day.
And then wait, and then 2, like I just shouldn't have.
2 divided by 8, that would be 0.25.
Okay, thank you. That makes sense. That makes a lot more sense. Trying to figure out what's wrong with it.
What? So, can someone tell me one that worked for the first one? What'd you get? Seven over 8. Oh, my screen is frozen. Let me unfreeze it. You didn't check them with your calculator? Okay, I'll erase it here. What's one that worked? What do you got? 1/4, 3/5, 8/9. 3/6? Quick check. This is 0.25, this is 0.5, and this is 0.8 repeated. Yes, those are in the right order. Yes? 1/9. Sorry, what were the next numbers? 3/8. 2/8. And then 3/7. Yes, that'll work as well. Yes? Ooh, added the 0. Zero halves. 3/7. Ooh, 9 over 1. And what's nice about this one is that, what's the difference between this and this? A lot. Got a difference of 9 between them. Check what your biggest difference was. Did you get close to that? I think that is the biggest you can get. What about smallest difference? What are some numbers that people got here? How close were you able to get them together?
I got 3/7, 4/8,
3/7, 4/8, and 5/9. And so what did that make the difference? Did you calculate it? Because you had, okay, we can pull that up. You had 3/7 here, and what was this one? 5/9. So if you wanted to check on your calculator, I'll pull up my calculator here. If I want to figure out the difference, that would be 5/9 minus 3/7. 0.1269. So this is someone found one, 0.1269, which is pretty small. Is that the smallest one? We don't know. That would be, you'd have to check to see if you could find one bigger or smaller than that. Okay, level 2, just one answer for level 2 that works. Yes, what'd you get? 20 over 85. 6/9. 37 over 41. And then you checked it with your calculator to see if they were all in the right order. Perfect. Excellent. Okay. So this was our warm-up. Again, with these warm-ups, I'm certain that 9 is the biggest that you can get for the biggest difference for this. The smallest difference, 0.12, seems really small. We'd have to check to see if that's the smallest one. But it, biggest difference that I got for, what did I get as the biggest difference? I got 97.697 on that one. So see if you can find a bigger number difference than that between this number and this number. But I didn't get a smallest one yet. Okay? Now, challenge yourself even after we go outside of class. Can you find something smaller? Or if you have a friend in class that you say, okay, I think we're relatively at the same level of mathematics, challenge your friend who can find the smallest one, right? Because you will do lots of calculations and mental math by doing these. Okay, let's go back to our notes. We were on page 12 in our note package. I want to turn to page 12. And we're continuing where we were working yesterday, which was just understanding our real numbers, our decimals. And what we're going to want to do, and were you able to get everything from the videos and stuff? Awesome. Perfect. Great. Well, that worked out all right then. Okay. So, yeah, okay. Sounds good. Yeah, for sure. Okay. So the first thing I want you to do is to draw a dot on the number line where 1.25 is and a dot on the number line where negative 3.26 is. Got them on there already? Good. So we're on page 12.
Well, we're not supposed to be there yet.
So draw a dot where 1.25 is on this number line and where negative 3.26 is on the number line. Okay, you have 10 more seconds to get your dots on there. And then I'll give you a check. Hey, how did you do? Did you get your 1.25 dot? right there. And your negative 3.26 dot right there. Now, the question is asking us to write two integers. So this is a definition we learned at the beginning. Do you remember what integers were? Whole numbers that are either positive or negative, and including 0. Do you remember the symbol for integers? I with 2 lines or the Z with 2 lines. So those are integers. So what are possible answers? We could have 1, we could have 0, -1, -2, and -3. Those are the possible answers. You just had to write 2 of them. So if this was a quiz, you could pick any 2 of those, and you'd be right. Okay? Next one, label 1/2 and 1/4 on this number line. So each number line is changing a little bit, right? You have to figure out what's the scale of this number line, where are those values going to be, and then you have to come up with 2 decimals between -1/2 and 1/4. Again, 10 seconds and then I'll label them. All right, how did you do? Did you get -1/2? Right there. Okay. And 1/4 right there. Now, if you didn't get the quarter perfectly between the 2 and the 3 on this one, you're having trouble with that, one of the things you can do is you can take out your calculator and you can change these to decimal places, because that could help you. The -1/2 is -0.5, and 1/4 is 0.25. Next thing, just to ask you, can you see that in this scale that just the 0, the 0.5, and the 1 were listed? Could you label the other lines in between? Okay? So part of this is figuring out how much is it split up into. Did you see on this one that this would be like 0.1, 0.2, 0.3, 0.4, 0.6, 0.7, 0.8, 0.9, 1.0. Being able to figure out the scale that is given in the number line is going to help you. Now, 2 decimals in between. Could you see that you could have chosen 0.1? Is 0 a decimal? Well, you could argue that 0 is 0.0. I don't know. Maybe you would feel like you wouldn't want to include that. Maybe you could include -0.1, -0.2, -0.3, and -0.4. Is this all the answers? No, why not? Because there's like a lot of them. What would you call, I'll draw a purple line somewhere, right there. What would you call that purple number if you had to estimate it? First of all, I'd say it's negative. -0.28, like it. Because this would be -0.1, this would be -0.2, this would be -0.3. He's making an estimation that it looks like it's closer to the -0.3 than it is to the -0.2. So -0.028 would be another example of a decimal in between. English language. When we talk about decimals in the English language, we say 0.28. We never say 0.28. Did you know that? That decimals, you just say the numbers and list them. You never like read it out like a 28 or a 25. You'd say 0.25. You'd never say 0.25. Did you know that? Yes? Yeah, yeah, I'm looking at you. Did you know that? No? Well, there you go. Learn something. Okay, next one. Ooh, no scale is given. You create your own. Decide what you're going to have for these. And then write two fractions. Whew. This is a little bit of a challenge. On the next page. Okay, I think this one is a challenge. One, because it's negatives. And so, first of all, on the number line, can you see that the negative 0.36 would be further to the left than the negative 0.35? So I'm going to put them here. I'm going to put negative 0.35, and I'm going to put my negative 0.36 here. Do you notice that some of the lines are a little bit longer? Why did they do that? Sort of breaks it up. How many lines are in between the two longer lines? There's 10 different sections as a result. So if I did this, this would be negative 0.34, and this would be negative 0.37. Those are my big lines. Now, if it's broken up into 10 sections, every time you break it up into a section, and I'm going to label these, I would have negative 0.351. Then the next one would be negative 0.352, negative 0.353, 354, 355, 356, 357, 358. I'll just do another one, negative 0.358, and so on. Do you see how breaking that up into 10 sections goes into the next decimal? Now I need to write two fractions in between here and here. And I've labeled some decimals, but decimals aren't fractions, right? So one of the answers could be negative 0.351. Do you remember how to write that as a fraction? This would be negative 351 over 1,000. And another one I could pick, negative 0.352, which would be negative 352 over 1,000. And that fraction I could reduce, but in this question it just said to list two fractions in between, so technically, even though it's not reduced, that is a right answer for this one as well. Whew. So, would you say this one was a little bit harder than the last one? Definitely. Probably the hardest one we've done so far. You ready for the next one? First of all, again, I want you to label the numbers on there. And then, do you remember what a mixed fraction is? Close. That's an improper fraction. Right, a whole number and a fraction. So a mixed fraction would be, for example, like negative 1 2/3. That's an example of a mixed fraction. And it happens to be between those. That's a mixed fraction. Has a number and a fraction together. So what we're just trying to do here is get a sense of where numbers are. Just the same thing we did with our activity at the beginning to make fractions less than each other. Same thing here, we're trying to put numbers in between. Mm-hmm. Yeah. There's 1.25. And there's negative 3.26. All right, now we're going to play a little challenge with this one. We're going to get an example of mixed numbers. So a mixed number would be anything with, a mixed fraction is anything with a whole number and then a fraction after. And we would need anything in between 1.5, 1.25 and negative 3.26. Okay? So for example, can you see that anything in the negative 2's would work? Anything in the negative 1's would work. Zeros wouldn't work because then it's not a mixed fraction. You would just have like 1/2 or 2/3. It wouldn't really be a mixed fraction. So you're not going to have any answers in here. There would be a few answers with 1 and a fraction. And there would be a few answers with negative 3 and a fraction. So the way this game is going to work is I'm randomly going to pick someone to start. And the person who starts says a mixed fraction in between. So let's say it was randomly me, and I said negative 1 2/3. Then what's going to happen is after I pick the random person, the person immediately behind them, and we'll go in this direction. So once we get to the end of the row, like once we get, to Griffin, it'll start over at Nevea. Okay? So that'll be the order. I'll give each of you a number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. To find out who goes first. I rolled a 28. Nobody was a 28. 14. 1, 2, 3, 4, 5, 6, 7, 8. 14. Okay? So right behind Nora, if we're going this way, we'd go to the top of this row and then down and down. So you're next. Okay? So what Nora says is she says any fraction in between negative 3.26 and 1.25, any mixed fraction. So pick one. Negative 2.5. Perfect. Would everybody agree that that is? No, you don't have to write them down. But this is just the challenge that we're going to do for this. She said negative 2.5, and now she's either going to say bigger or smaller, and the next person has to still do one in between, but they have to do something bigger or smaller than negative 2.5. So what would you want, bigger or smaller? Smaller. So now, Kale, she just did negative 2.5. You need to have a mixed number that is smaller than negative 2.5, but still has to be bigger than negative 3.26. Yeah, that was a hard one. And you don't have a lot of room to work with, right? But what would be a mixed number that would be in between there? You could either do negative 3 and something in this section, or we could do negative 2 and something in that section. And you guys can see you can be nicer or meaner to the person next to you depending on which section, right? You could just keep going smaller and smaller and smaller, or bigger and bigger and bigger. So, Kale, what would you like to try? Would you like to try a negative 2 number in this section, or a negative 3 number in that section? So that's your first decision, which that part doesn't make it right or wrong. We're just trying to decide if you wanted a negative 2 number in here or a negative 3 number in there. What would you like to try for? Negative 2 or the negative 3? And it really doesn't matter which one. So this is just random. Pick one of those two. You want to go with the negative 2? Or do you want to try the negative 3? Yeah? Negative 2? Okay. So now we got a negative 2. Now how are we going to get a fraction? Has to be in between here. So we've got negative 2.5. We would need, does it make sense that the fraction that you got to have there has to be bigger than a half to get closer to negative 3? So can you tell me a fraction bigger than a half? Yeah? 3/4? Does that make sense that 3/4 would be larger? So then we get negative 2 and 3/4. And now you're passing it on. Do you want to do something bigger or smaller?
Smaller.
Well, you've got to pick one, though. It's part of the class. Bigger or smaller? Yeah. You just get to pick. It really doesn't matter. Bigger or smaller? You don't care? No. So just pick one, because if you don't care, it doesn't matter when you pick it. Bigger or smaller? It goes to you next. But we just need to pick one, bigger or smaller. Or flip a coin. Could be. Okay, easy. Okay, we went bigger. We went bigger, and it's bigger to you. What do we got? 1 1/10. Ooh. 1 1/10 would be right there, right?
Bigger.
You going bigger or smaller? You're going smaller? Oh. -2 and 1/5. So -2 and 1/5 would be right there. Bigger or smaller? Smaller. -3 and 1/4, which would be right. Oh, that. Oh. Okay. Bigger or smaller? He's going bigger. Oh, that was. Okay. Anything? Two and a quarter, though, goes past the limit. Our limit's at 1.25. You'd be over here. -2 and a quarter? Okay, that would be -2.25. That would be right there. Bigger or smaller? Bigger. Kyle. -2 and 1/8. Yes, that'll be. It was bigger, but just a little bit. Bigger or smaller? Bigger. -2 and 3/5. Now, if I went -2 and 3/5, that'd be -2.6. That would be here, but you need to go bigger than his. -2 and 1/12. Yes, that would be like right there. Bigger or smaller? Smaller. So we're right here, -2 and 1/12. -3 and 1/4. All right, we're back to here. -3 and 1/4. Bigger or smaller? Bigger. Oh, again. We've got to that -3.25 a couple times, and people have been nice. -1 and 3/4. Yeah, we did. That's okay. But we can add new ones too. We couldn't make a rule that you can't add a new same one. But okay, we're at -1 and 3/4. Bigger or smaller? Smaller. -2 and 1/4. There we are, right back there. Bigger or smaller? Bigger. Okay, 1 and 3/10 is just barely over, but you can 1 and 2/10. Okay, yes, that's right there. Going bigger or smaller? Bigger, all right. Whoa, thousands, thank you, yes. So that is like bigger. Okay. Yeah? Whatever what is. When there's more zeros? Woo! That is just a tiny bit bigger, but it is bigger. Are you going bigger? Bigger! Okay. Yeah, did anybody notice it was like all nice, all nice, all nice, and then wow, just turned up a level, got to that row? Okay, what do you got? 1 and it's got to be bigger. Ooh, over 10,000? Yeah, we can go bigger. Why not? Going bigger. 2499. Oh, he brought it right to the edge. And you're going bigger? Oh, this is getting crazy.
No, you just say 9 repeatedly.
But I showed you the 0.9 repeated would make it 0.5, then it wouldn't be in between. Oh.
It's not
Are
really.
you going bigger or smaller? Last one. Bigger. Oh. Okay, Cass. Can you do it? 1, 0, 0, 0, 0, 0, 0, 0, 1. Wow. But we're down. Now we've went all the way around. Okay. Oh, yeah. Bigger. Well, then I could just change that to a 2. Right? So it's interesting that even with fractions or with decimals, we could do the same thing. There's never ending. And this really, like in this question of can you put two numbers between, there's a lot of answers that are possible, right? Okay, I think we got two. Do we even need to do this one? No, we can probably skip it. Okay, let's move on to another topic. Ways of representing fractions. There's proper fractions. Proper fractions, the number on the top is less than the number on the bottom. So proper fractions always end up as a decimal between 0 and 1. So you have 1/2. Can someone give me another example of a proper fraction? 1/4, yes, you may. That would be, so the number on the top is smaller. You could have 2/3, that would work. 9 out of 10, that would work. Those are all called proper fractions. Then we have improper fractions. That's where the number on the top is bigger. So 4/3, 9/7. What would be another example? 8/5. There's tons of them, right? And in the activity we did at the beginning, when you wanted to find the biggest difference, most of the time you had an improper fraction as your biggest one, like 9/1, to make it as big as possible. And then there's mixed fractions. Now, mixed fractions like 1 1/3 or, I don't know, 1 and 249, 9/10. I don't know where that number could come from. Those would be mixed fractions, and that's what we were doing in our activity right before this. We were working with mixed fractions. Mixed fractions are nice for understanding where the number is. Like it's pretty easy to see that this mixed fraction is between 1 and 2. It's not always easy to see where an improper fraction is. So for example, would you agree that 16/5 is the same as 3 1/5? Okay? But I think the improper fraction is easier to visualize how much you have. I have 3 and a fifth. And if I go to my favorite visualization, I think about chocolate bars, right? I have, oh, my youngest son, so nice this morning, said he went to Dollarama last night and bought me my favorite chocolate bar and gave it to me for Valentine's Day today. But I only got 1. He didn't give me 3 and a fifth chocolate bars. Wow.
Actually, that was pretty funny as for a math teacher.
Yeah, or just a fifth. Sorry. It was really good. Here's Happy Valentine's Day. Here's a fifth of the chocolate bar. I knew you were a math teacher and liked fractions. So. Okay, so when we talk about 16 fifths, it's harder to visualize how much chocolate you would have. If you're like, oh, I have 16 fifths, that would be like opening up 3, 4 packages, breaking them into fifths, and then just giving the pieces that way. So mixed fractions are nice for understanding what the number is, but improper fractions, a lot of the mathematics that we do with fractions, it's actually easier to use improper fractions. So something we have to do along the way is we have to be able to switch back and forth. Do you remember switching? So let's, like, I wrote it there, so let's do another one. Let's pick sevenths, and let's do 24 sevenths. How would you change that to a mixed fraction? What did you do in the past? Put 7 into 24 as much times as you can, which is how many times? 3 times. You're right. You can fit 3 full 7s into 24 because that gets you up to 21. You can't put 4 in there. And then how do you do the next part of the mixed fraction? Right, because 3 full 7s would get you to 21, and then you're left with 3 little pieces left over, so it would give you 3 and 3 sevenths. So that's a good way from working from this direction to this direction. What if we were going the other way? Let's say I started with 4 and 2 ninths. How could I write that as an improper fraction? How do you work the other way? So 4 times 9, which makes how much? 4 times 9? 36. Plus 2 more would give you 38. So you did the 4 times 9. Again, if you were thinking about, and I don't know if there is a chocolate bar that breaks into 9 pieces. If there is, you can buy it for me. I'd be very curious.
I'll look it up.
Okay? So you have 4 full chocolate bars. And then the last chocolate bar, you just have 2 ninths or 2 of the 9 pieces. And each of these chocolate bars can be split into 9. Wow, I shouldn't have chose 9. You just imagine. Can you imagine those are 9 pieces? We can use our imagination a little bit. The reason we do 4 times 9 to get 36 is because you had 4 full chocolate bars of 9 pieces. That makes 36 pieces plus the 2 extra makes 38 over 9 as an improper fraction. Okay? That's the reasoning behind it. I think, as far as a math teacher, I would tell you when you want to change 4 and 2 ninths to improper, well, you do 4 times 9, 36 plus 2 is 38. And that's, oh, I love Toblerones. Okay, that's such a good. How many letters in the word Toblerone?
1, 2, 3, 4. 9.
Yeah. Nice. I'm so sneaky. Okay. Yeah. Because Toblerone has the letter on each chocolate, right? When you open it up. There's the T. Oh, you haven't. Oh my goodness.
Bring some to learn.
Yeah, I think we have to have a. Okay.
It costs like $50 for the math.
So, to bring it back to here, as a math teacher, I would tell you, hey, you change it by doing 4 times 9, which is 36, plus 2 is 38. But when you visualize 4 Toblerones, you would have 34 times 9 pieces there, and then another 2 extra. Then you can see why it works. And that's something really important for mathematics, is that you always try to figure out why something works as well. Okay. Can you write 2 3/4 as an improper fraction? This is one for you to try. I'll put the answer up in a second.
Roll on your here. I think you need to redo it. No, it's not. Oh yeah.
All right. Were you able to get it as improper fraction would be 11 over 4? How about your decimal? Did you get the decimal?
Yep. 2.75.
2.75. All right. You ready for... How about I'll give you one more. I want it as... I'm going to give you an improper fraction. You have to write it as a mixed fraction and then tell me the decimal. Ooh, that's close. I'll do one close to that. How about we do 61/9? Change it to a mixed and change it to a decimal. That would be a lot of Toblerone bars, by the way. Changing that one to a mixed. 61/9 to a mixed and to a decimal. What'd you get? Yes. Nice. All right, how did you do? Did you get 6 7/9? And as a decimal, this would be 6.7 repeated. Woo! All right, next one for you to try. Put all of those in the proper place on the number line. You've already done it? Good. Perfect. Thank you. So, Kale, right now we're working on putting these ones on your number line in the right spots. And just a reminder, if you could put your phones, instead of being on your desk, if they could be in your pocket or away in your backpacks, that would be great. Oh. So, homework for you guys is to finish page 15 and page 16. Okay,
I have to complete 15.
page 15 and 16 is not very much, it's a couple more number lines. And you can work on that right now, and that'll be your homework for tomorrow. This is where we'll end for today. So, with fractions, you can change them to decimals, label them on there,